Hello students, in this video we are going to look at the seasonal adjustments for linear trend line, and this is the last video in forecasting series of videos. See, in the last video we have seen the linear trend line, so we will be using that linear trend line approach in this. Here what exactly is the data given to us is basically we have been given the quarterly values, maybe for demand for a particular set of years, say 3 years, 2003, 4 and 5, quarter 1, quarter 2, quarter 3, quarter 4. So this is what demand in thousands is given to us. So this is our starting point of the data. First, what we are going to do is to calculate the total for the entire year. Simply by adding this you will get this, simply by adding this you will get this. So once you have this year wise the totals, so I have just recaptured that here, year wise totals. It looks like our linear trend problem, right? We have year and we have some parameter which is changing year after year. So to get the next year, so what is our challenge here? We need to find out the next year's 4 quarters values or demands, right? So first we need to find out the entire 4th year's total, what will be the demand. So for that we will be using linear trend line, which we have learned. So we will be using this equation. So in case you have not seen my previous video, linear trend line ka video, I suggest you see that so that you understand this. So using these two formulas we are going to calculate A and B. So first we will have to create 2 more columns. This is our Y, sorry, this is our Y, this is going to be our Y, and this is going to be our X. We are going to create 2 more columns, X into Y, X into Y, and we are going to create X square here. So these 2 columns we will create, and then we'll do the calculations and we will do the totals and use this into this equation. I suggest you see the previous video, linear regression. So once you have done this, you establish this A and B. So your equation becomes Y equal to 40.9 plus 4.3 times X. So for X equal to, for 2006, X will be equal to 4. So when we put X equal to 4, we get the total annual demand for 2006 as 58.1. So now this 58.1 we need to divide it in the 4 quarters. So for that, what we are going to follow, we are going to find out seasonal factors. So what exactly is the seasonal factor? So if you look at this table, now we will find out what is the total for the quarter 1, what is the total for quarter 2, quarter 3, quarter 4, and this quarter 1 value total divided by the entire year total, right, will give me the seasonal factor. So if you look at this seasonal factors which are calculated here, you can see this one is nothing but quarter 1 total upon the grand total, right? Season 3, quarter 3 total upon the grand total. So you will find out these 4 seasonal factors. Now you will use these seasonal factors, this information and this information together. Simply just multiply each seasonal factor with its grand total, which will give you the, see here, this one multiplied by 58.1, which is my grand total, right? So you can also do like this. Instead of writing this, you write this and use F4 and do this, right, and then simply you will get the same answer. So if you, so this divided by this total annual demand is your quarter 1 demand. Similarly, you find out quarter 2 demand, quarter 3 demand, and quarter 4 demand. and because we have used thousands, these values were in thousands, so just multiply it by 1000 to each one of them, and it will give you the demand in units for the 4 quarters in 2006. So this is how simply when we use simple linear trend approach, we can easily find out the seasonal forecasting for the coming year, right? Here seasons are considered as quarters, but if you have different values, if they are not matching with your quarters, if 4 months is becoming a season, then you have to change your approach little bit, so that you can get then 3 seasons of 4 months, and you can use the same logic. But mostly you will find the quarter wise calculations are done. So this is the end of forecasting series. Thank you.